Hello. In this video, we're going to look at another application of the law signs. All right. So this problem comes from the book Analytic Trigonometry with Applications by Barnett, Siegler, and Bilene, the 11th edition. And you look in their law signs chapter, you'll find it. All right. So they give me this picture, and they tell me that this is a hill. You probably might not be able to see that so well, but here, let me draw that in. Here's the hill. Right, and the tree actually is right there. And they're saying here that a tree growing on a hillside casts a shadow of 157 feet straight down the hill, and find the vertical height of the tree relative to the horizontal. The hill slopes at 11 degrees, and the angle of elevation of the sun is 42 degrees. Now, sorry about this, but this shadow is like here on this hill. Okay, so you can see it. So this is the hill. All right, so again, I usually encourage you to go ahead and pause the video and see, how you do on this problem. This one's a little bit more challenging. Even labeling is going to be a little bit challenging. So, and I would definitely say you should pause the video, draw the triangles that represent this, and label as much as you can. That is a skill you need to get. So practice it. The only way you're going to get it is by practicing it. So that's your first step. Draw the triangle, label what you can, hopefully you can get all of it, and then go ahead and start the problem. And I will tell you this, that the strategy, one of the reasons I like this problem a lot is it really goes into one of the strategies I use where when there's a lot of stuff to find, sometimes it's easy to get lost. So what do I do to not get lost? Well, I start at the target, what I want, which in this case is the vertical height of the hill, of the tree right here. And then I work backwards and say, okay, well, what do I need? I need this. Oh, well, how do I get that? Well, I would need that over there. And what I do is I work backwards from my target, and I just label it what I need at each point with a number. I don't try to figure it out. So that's kind of key here. I do not try to figure out each step along the way. I just sort of label it going, okay, I'm going to assume I can find that. And then what was the next thing? I'm going to assume I can find that. Okay, so I'll show you that technique. But go ahead and pause it and see if you can label this. So I'm going to go ahead and do that. So here we go. All right. So I'm going to do this in red so I can write over it pretty well. All right, so I've got some kind of here, because it's coming from the sun, right? The angle, the shadow. We're going to extend all this down, because they do talk about a horizontal. And so where a horizontal and a vertical come together, I'll have a 90-degree angle. And then I have some kind of hill, right? And then, now let's look at this problem. So this is the tree, right here. Right there. And what I'm looking for, they tell me that my goal is to find the vertical height of the tree. So this is what I want right here, right? What is this height? So that's actually the first thing that I want. So that's what I'm talking about labeling. I start going backwards. So let me go ahead and label what I know. It says the shadow is 157 feet. So that's because there's a sun here, right? So let me just draw that in here. Sun. Cast is here, and it casts the shadow. So this is 157 feet. And then what else do they tell me? The hill slopes 11 degrees, and then the angle of elevation of the sun is 42 degrees. All right, so now the angle of elevation is always an angle relative to the horizontal. This is my horizontal right here. This is horizontal. So that means that when I'm looking at the angle of elevation to the sun, if this is the sun, right? So that would be this triangle right here. Then that means this whole angle right here is the angle of elevation, 42 degrees, okay? So then this 11 degrees, the hill slopes at 11 degrees, meaning this little piece in here. So this is 11 degrees, where from the horizontal to the hill, that's the slope of the hill, okay? So there's your labeling, which is challenging. This can get challenging. All right, so now I'm going to apply the strategies as I've mentioned. I'm going to say, okay, I want this. Now, how would I get that? Well, I sure wish I knew this angle right here, because this angle forms this side. Now, I don't care that it's pretty simple to see that this whole angle is 42 and this is 11, so this is the subtraction, but I need to just label it. I need that angle, so I don't want to get confused in the details yet. If I had this angle forms this side. That's really great. But unfortunately, I still would, having this angle and having this side that's unknown, that's one unknown, I still need to know some more stuff. So I know this side, but I wish I knew what? This angle right here. All right, so if I knew that angle, then I could say this angle forms this side. If I knew this angle, then this angle forms the side that I want. All right, great. The problem is I don't know either one. Even if I knew this one, because it's kind of simple, I still don't know that one. So I sure wish I knew this one, because then the sum of all three, right? Because you can kind of say that even though this is, I've drawn it kind of like a slope, I can say that's really a straight line. So this angle and this angle together plus this one would be 180 degrees. So I think I really need this angle, right? Then I could start working. If I knew this angle, and I know that angle pretty easily, then I can find that one. But to find this one, I probably need, what? This one, right? Because I know these two would be 180, or I could say, and then I could say this one I can find because I can then know this one and I know that one. Ah, finally. See, by working backwards and just labeling it with numbers or letters or whatever you want to, identify how to work backwards, but not getting involved or lost in the details. I finally got to a place where I'm like, I know I can find this, okay? Because I know this one, and together all three are 180. I can find this. If I can find this, I can find this. If I can find this, I can find that. If I can find that, I can know that, and then I can find that one. There I am, okay? So now I know how to start. So let's go ahead and start. So to find angle 5, all right, that's 180 minus 11 minus 90, right? So let's go ahead and do that. So that's going to be 79 degrees. Yay! So this is 79 degrees. If that's 79 degrees, I know that to find angle 4, I know that 180 minus 79, right? So here we go, 101 degrees. So now I know that's 101 degrees. Now, I knew I could find this one pretty easily, so I can do 42. So to find angle 2, I can do 42 minus 11, right? Oops, that's not, it's so easy to write stuff funny. So that's 31 degrees, right? So that's 31 degrees. And now I know these two, right, subtracted from 180 will give me that. So to find angle 3, I'd say 180 minus 31 minus 101. And I get 48 degrees. All right, so now this is 48 degrees, yay. And so now I finally know this angle forms this side as this angle forms the side that I'm looking for. So let me go ahead and set that up. Okay, so we're almost there, which is good. All right, so I want to put the side that I'm looking for on top. So I'm going to go H is to the sine of 31. That's the angle that forms it. As 157 feet is to the sine of 48. All right, yay. Now we're ready to go ahead and solve. So I'm going to multiply both sides by sine of 31. Just remember, that's just a number. So now H is sine of 31 degrees. And be sure you're in degree mode, by the way. You put all this in. It's really easy to be in radian mode or something. All right. So now, let me just bat that out. Sine 31, don't forget your parentheses after the 1, divided by sine of 48 degrees. And I get 108.8. So they're probably going to say like 109, and this is feet. Okay, so now we know 109 feet. All right. Let me just show you that again. And there you go. All right. Thank you so much for listening.